In this video, I'm gonna explain you the problem called My Calendar 3. So this is the problem of the day on the Leetcode. So there are the variations of this problem, which you can see. There are similar questions called My Calendar 1, My Calendar 2, and this is count integer in intervals. So I feel able to understand the approach, the logic behind this problem. These are problems called My Calendar 1 and My Calendar 2 would be the easier for you. So what I'll do in this problem, I'll explain you the approach, the intuition behind the solution of this problem from the scratch. So first, I'll talk about what actually the problem statement is, and then I'll gonna talk about one of the problem, uh, which is the another problem, the logic of that problem we're gonna use to solve this problem. And also I'm gonna talk about the two different approaches to solve this problem, and I'm gonna code this problem out here live. So let me reset this. So let me explain you the problem. So the problem is a K booking happens when K event have some non-empty intersection. So there is some time that is common to all K events. So what the problem is being saying that you are given a K booking. I mean there are some events. So if K booking happens when there is some common interval or the intersection. Uh, the intersection is for k different events. So you are given us some events start and end. So here you can see this is the uh, open bracket. So after each event, so this end is not included over here. Starter is included and end is not included. So after each event, return an integer k representing the maximum k booking between all the previous events. Okay, so hope the problem is clear that at every point of time, whenever this book function we're gonna call, so after adding that event to the current events, we have to return the value of k, and the value of k is showing that k booking. So we just have to, actually the thing is that the simple problem is that actually we need to return the maximum event. So maximum intersection interval. So if you have there's a problem called maximum intersection between the intervals. So we just have to return what is the maximum number of events uh, which are intersecting to each other. So that's the value of k. So we just have to return that value of k. So let me go on the board. So I'm gonna explain here. So actually, at every point of time, what will be given to us? So will be given two values. One is called start, and uh, okay, and another one is called end. So we'll be given the start point and we'll be given the end point, and we're gonna have all the events till now. And after that, let me explain you like what exactly you have to return. So let's say this is called there is some events, maybe some events. So what I like the events are like this. If I'll denote those events on the number line, so those events would be like this. So this is the starting point of that event and this is the ending point. So let's say this is one of the event, this is one event, and let me say this is one of the event, and let's say this is also one of the event, and let's say this is also one of the event. So now let's say these are the events, and now if they are asking that what is the at this point of time what is the value of k, what is the maximum value of k, what is the maximum intersection of the events. So you will able to figure out like the intuition behind is this, that like let's say if you're gonna draw the vertical lines at every point of time, like let's say at every integer value you are drawing some vertical lines. So actually what we need to return is the at any point of time, at any vertical line, the maximum intersection of that vertical line to these lines, these horizontal lines. So let's say there could be multiple lines. Let's say let me just give you some example. Let's say sorry for that. Actually, sorry. Okay. So I can draw one of the line over here. Sorry, just ignore this. And let's say if I'll be draw line somewhere here. Uh, you can understand, like if I'll draw some line at this point, and if it'll go in this way and this, so you can just see this line. What's happening over here is that this line is intersecting to the four horizontal lines. So this is at this point of time, if you will draw at any point of time, like here you'll get two intersection, and if you'll draw here you'll get three intersection, so like this, and here you're getting two intersections. So if you'll draw this line over here, so what I'm getting is that here I'm getting at max four intersection. So at this point of time, the value of k is 4. So actually this we have to return. So dynamically we're gonna receive the starting and ending point, and after inserting that starting and ending point, we just have to return that what is the maximum intersection behind maximum intersection between all the current events. So first, to solve this problem, I'll just explain one of the problem. I'll give you the link of that problem as well. You can just try that out. So let me erase this. So the logic of that problem we're gonna use over here. So what problem is that initially you are given an array. So you will be given the length of the array. Let's say, let me draw the array. So there would be some length would be given to you. So for example, in this case, and I'll just create the indices 0, 1, 2, 3, and 4 and 5. So in this case, the value of n is what? 6. So, and initially, all these indices will be initialized with zeros. And this is very actually the very nice techniques, and this techniques which I'm gonna explain you. This is kind of prefix technique, but this techniques, believe me, this technique is used in a lot of problems. I've solved a lot of problems, and I've seen this particular techniques is being used in a lot of problems. So this is very important. You should understood that what the technique is. So the problem is that you are given initially you are given an array, and at every index the value is containing 0, and now you'll be given some queries, right? So there will be some queries, and in queries what will be given, you will be given the starting index, same the starting index. So there will be some starting index, and there will be some ending index, and there would be one value of k. So what you need to do is that you just have to add this value k to the starting and from the starting to ending index. You just have to add that value to all those indices. And finally, at the end, what you need to return? You have to return the maximum value at any index. At the last, you just have to return what is the maximum value is contained by any of the index. So there would be queries. So like there could be this simple solution for this. So what could be the solution is that the simple solution, if I'll talk about what you can do for each and every query, you'll start from the starting index and you'll go till ending index. And at every index, you will gonna manually gonna add those values, the value k, you're gonna add into that. And finally, when you'll be done with all the queries, now what you can do, you can just iterate through entire array, and you'll get the you can just find the maximum value out of that. So in that case, let's say this condition is that at max my value will be between the value of n will be between uh, so value of n will gonna lie between uh, 10 to the power 6, and the number of queries will be also, let's say, 10 to the power 6. So in this case, you can understand if there is the value of n is lying between 10 to the power 6, and value of q is also lying between the number of the 10 to the power 6. So in this case, if you perform this kind of operation, you'll go you'll just iterate through each and every starting and ending index for each and every query. So as in the worst case, what could have happened? So every time, let's say you're getting the starting as 0, the first index, and the ending as the last one index of the array. So in this case, what number of iteration you will do for each and every query? you can just see that there would be 10 to the power 6 iterations, the number of elements in the array. And finally, this how much this 10 to the power iteration, how much time you will have to do? That is 10 to the power 6, because you have the 10 to the power 6 queries. So finally, this will become 10 to the power 12. So now you can understand is that the 10 to the power 12, you'll not able to, so this is obviously will gonna give you the time limit exceeded. It will gonna definitely gonna give you the TLE. So this approach is fine. This is the brute force approach, but this will not gonna work. So now let me explain you the optimized approach, which you can solve this problem in just how many number, what the time complexity, that is just n plus q, order of n plus 2. So how you'll able to do that? Let me explain you the approach. So just understand what you need to do is that you'll be given some queries, and you'll be just given some queries, and you'll have to add from the one of the index, and at the end, I mean from starting and ending this, you just have to add that value. So let's say like this, the indices are coming like this. Let's say 1 to 3, you have to add, let's say 2. Fine. Let me explain you more things. So 2 to 3, let's say you have to add 3. Okay, fine. So instead of adding in each and every indices, what you could have done, that is from 1 to 3. Actually, the at the end, the logic which we're gonna use, that would be prefix sum. So prefix sum that would be required at the end. First, let me explain you how you need to do this operation. So you just have to start with 1. So you have to add 2 over here with this index, right? So what you will do, you just add 2 to the this current value, right? And till till which index you have to add this? You have to add this till third index. So here third index, you can understand this one. So starting with 1, 2 and 3. Now what you will do, you will subtract 2 over here. Okay, fine. To the next index, till I mean, what are the next index? To the current, the ending index, you will just subtract 2 over here. 2 means what are the value of the k is given. Now in this case, you can understand it is starting with 3 and going till 3. Starting with 2 and going till 3, and you have to add 3. So starting with index 2, so you will, what you will do, you just add 3 over here, and again you will subtract 3 from here. Okay, fine. So let me explain you. At the end, what you will do, since you can just understand that this value, this 2, should be added to the index 1, to the index 2, and to the index 3, because the starting index is 1 and the index is 3. And finally, 3 should be added to this 2 and 3. So you can understand the common part. This 2 and 3 values being added, these 2 and 3 indices are common. You can understand the 2 and 3 is over here as well, and 2 and 3 is over here as well. So with this 2 and 3, both the value of this 2 as well as this 3 should be added, right? Should be added. So now at the end, I can just perform the prefix operations over here, a kind of prefix array. So I'll just start from the beginning, and I'll just take the prefix sum in the sense, I'll just add the previous value to, I'll just start from the beginning, and I'll add the previous value to the current one. Same I'll do with each and every indices. So if I'll do after, let's say, after performing the prefix array, my array would be like this. So let me do this first. So this was it. There are total 6, so 3 and 4, 5, 6. So 0, 1, 2, 3, 4, 5. So now you can understand this is 0. So 0 is fine. Now at index 1, we have added 2, right? Okay. So now at this index, this 2 will be also added and this 3 will be also added. So at the index 2, you can understand you will gonna get 6. Here I do have 0. So this directly I'll just add, the previous one value is 6. So 6 would be directly added. Now at index 3 is fine. Now you have to understand at index 4, at index 4, the previous value plus this current values. So the current values, you can understand, minus 2 plus minus 3 is what? sorry for that. Actually, okay. So this is okay. This is not six. Sorry for that. So this is what? This is 5, right? 5, yeah. And this is also 5. And this minus 2 and minus 3 is what? Uh, minus 5. So 5 minus 5, 0. So this will become 0. And here again, our current value is 0 and the previous value is also 0, so 0. So at the end, you can understand the values we have to add, that is the common, between the common indices 2 and 3, both the values which is 2 and 3 is being added. And you can understand is that the 1 was only for the first index, so only the 2 has been added over there. So in this way, you can just perform these queries, and finally you'll just iterate through entire array, and you're gonna get the maximum array, maximum value out of it. So hope this intuition is clear behind this. So actually, we're gonna use the same intuition to solve this current problem. And I'll just want to talk about there is a one problem. This is the same problem actually. Let me just okay. This is the problem. So actually, this the problem which I explained. This is given on this HackerRank platform called array manipulation. The same logic, the same problem I have discussed. You can go through here. I'll put the link of this problem in the description as well. So you can just solve this problem. The same intuition I have explained, and this will gonna used to solve over this my calendar 3 problem. Okay. So I think hope this is clear. Now let me come on our main problem. Okay, so let me erase these things. Okay. Okay, fine. So now what I need to do, okay. So for this, you can just understand what's happening over here. That is, in this problem, I'll just talk about the constraints as well. So you can just understand. Okay, let me explain this input as well. So what the queries are coming, you just have to book this. The first one is that 10 to 20, right? So you just have to book for 10 to 20, and then book for. So at 10 to 20, you just having one event which has some intersection because there are only one event. Now 50 to 60, since these two events do not have any intersection point between these, so that's why the maximum intersection is 1 again. Now 10 to 40, since 10 to 20 is there and 10 to 40 is there, so between these two events, 10 to 20, so 10 to 20 is common between both of these. Or let me explain, let me say 10 to 19 actually, because this 20 is not included. So that's why here, but still there are two events which are having the intersection between each other. So that's why we are returning 2 over here. And now for 5 to 15, 5 to 15 we are getting 3. Why? Because this 10 to 20 as well as 10 to 40 as well as 5 to 15, these all has some common points, and the common points you can understand, that is 10 to 15 or 40. So 10 to 14, all these three has common. So that's why 3. Now 5 to 10. So 5 to 10 again, because 5 to 10 have finished over here only. That's why the common part is 10 to uh, 10 to 14 only. And now if we'll talk about 25 to 55, since these has 3 intersection and this is being finished at 14 only. So that's why here also the maximum intersection is 3 itself. Okay. So now let me explain the constraints as well. So the constraint is given is that the starting point is starting and ending point will be lies between 0 to 10 to the power 9, and there would be at most 400 scrolls will be made to book. So there would be at most 400 calls. So the time complexity, I'm going to talk about the time complexity. So one thing you have to notice is that in that case, in array manipulation problem, we were using the entire array, right? That was the entire array for each and every values. But here, what's been happening is that the starting and ending index is between 10 to the power 9. So in this case, obviously we cannot have this much large array which of size 10 to the power 9. So actually, Actually what's happening is that we are not concerned about all the events between that. We are not concerned about all the time stamp between that. We're just concerned what is the maximum event, what is the any particular event which has the maximum intersection. So what will gonna happen, let me clear it out. Let me clear it out why we do not need the entire array over here. So actually what we're gonna get, we're just gonna get the starting and ending point, right? So the starting and ending point, let's say we are getting 5 to 10. So one event is called 5 to 10 and one event is called, let me say, 6 to 11, and another one, let me say, 7 to let's say maybe 12. Okay, fine. Now, so the first event is what? The first event is between 5 to 10, right? So if I'll draw this, let me say, if I'll draw this, let me draw one number line over here. Okay, so this is since it is starting from 5 itself, so I'll just say 5, 6, 7, 8, 9, 10, 11, and 12. So this is 5 and this is 6, this is 7, this is 8, this is 9, this is 10, this is 11, this is 12. Okay, so the first event is 5 to 10. So 5 to 10, actually this is between 5 to 9. Got it? So 10 is not included. Fine. Now the next event is what? Okay, so this is between 5 to 9. Okay. Fine. The next event is what? 6 to 10. So I'll start with 6 and I'll go till 10. And the next event is what? 7 to 11. So 7 to 11. So this is 7 to 11. Okay. So you can just understand that there are 3 points. There are various points. Like what I need to do, what I need to get, I just want to have the value of k, right? And the k is what? The maximum number of events which is overlapping to each other. So one thing it's happening is that there are multiple points. What are the multiple points? You can just say this 8 point is also the 8 time spent is also what? At this particular time also there are three events are intersecting, and at 9 also you can just say there are three events are intersecting. But actually what's happening is that since I just want any of these, I just want any point of intersection. So you can just understand is that if this 7 to 7 to the one of the event was 7 to 11. So when 7 to 11 will come, so I want that starting point, because let's say there are two events which is already intersected to each other, which are so that those events are, you can, these were two events which was 5 to 9 and 6 to 10. So when 7 to 11 will come, when 7 to 11 will come, so actually if it will if this events will gonna start intersecting with any other events, so that should always be the starting point. We can just say ki, if that is intersecting with any of these event, so that would be the starting point only. The starting point will always intersect if this particular event is being used, or it is coming under the, if it is going to affect other events, or if it will gonna involve with other events to get the maximum number of intersection, then this is pretty sure that this starting point, the starting point of that particular event will always gonna intersect with the other intersection points. So that's why we do not need all these points. You can just say if there would be any new, let's say there is, let me explain. If there is some another events is coming and that is between 8 to, let's say 8 to 12, fine. So 8 to 12 if it is coming, so you can just understand if this event is gonna participating in the maximum number of events, maximum number of intersecting events, then starting points will always gonna participate in this part. a starting point will always gonna participated in this that. So what I'll do if I'll draw this line, so this is going between 8 10 to this is going between 8 to 11, right? So this is 8 to 11, fine. So here what's happening, the starting point is intersecting with these. So there are now four events which are intersecting to each other. So that's why we do not need that point. So it might also happen is that at any point, like if the 8 also can be participated and 11 also can be participated in that. Okay, fine. So now let me go to the. Okay, so hope this the intuition behind this problem is clear. So now what we're gonna use here. So in this to solve this particular problem, I'm gonna use the map data structure because I do not need all the events to be. I don't want all the points at any point of time. I mean, I don't need all points in between to starting and ending point. I'll just able to figure out with the any points in between the starting or ending points. I'll be able to figure out that that point is being intersecting with anyone else or not, right? So okay, so actually, and one thing is that if you want to perform all these operations, we should have at any point of time all the events should be in sorted way. So that's why I'm gonna use here the map data structure, and the map data structure is also not ordered unordered map. I'm gonna use ordered map over here. Okay, so let me code this out. So I'll just take one of the map and it will be having uh, the key value pair is integer and integer. So this integer would be for the integer for the key is the starting and ending point, and then here I'll just increase the values that how many events are there. So I'll just do +1 or -1 for that particular event. So at 5 if it is coming, so I'll just say at 5 this is the uh, I'll just +1, and whenever it will gonna end, so at that point of time, since here add is not included over here, uh, it has the open bracket, so that's why at end we're gonna subtract -1. So when we'll perform at the end, when we'll perform the prefix sum, so that would be subtracted. So okay, okay, I'll have to mention this outside of this constructor. So I'll mention over here. Okay, so now what I need to do is that events of start, so I'll just have to do plus plus, and events of end I'll have to do minus minus. Okay, now actually what I need to find, I just want to find the maximum overlap, right? And so maximum overlap is initially 0, and I'll have to use, since I at the what I'll be performing, I'll be having the prefix kind of things. I'll start from the beginning and I'll cumulatively gonna add. So for that I'll just use one current variable. Okay, so now I'll just iterate through the loop. So for auto uh, event or yeah, so for auto event, and now this events. So what I need to do is that current would be plus. So it would be plus of event. So event dot first is key and event dot of second is value. And now here my max overlap is equals to maximum of max overlap comma the current. And finally we can understand I'll have to return the max overlap because I have to find the maximum intersection at this point of time. Fine, and I think this is the very simplest code. There's nothing to that much hard, so you can just easily understand that what's been happening. Okay, so let me run this. Yeah, so let me submit this. Yeah, you can see it's accepted, And finally, I just want to talk about one of the different solution. So you can just code that out also, or I'll provide you the reference for that particular problem. So in that case, that is also the same intuition, but in that case, there is a problem called maximum overlapping interval. This is the problem available on the gigs for gigs. Actually, this problem is just the variation of this problem only. So this is the same problem, and what I need to do is that you can just understand that given different intervals, the task is to print the number of overlap, maximum number of overlap among the interval at any time. So this is the same problem and the same concept which I've talked about. The same concept is being used over here, and there is the same intuition, but they have explained it with inserting that into they have taken uh, one of the vector, and they are inserting like the same thing. They are adding and subtracting it. So they have used for x and y. So x is for incoming and y is for outgoing. So whenever like x will come, they are just doing plus plus, and whenever y is come, they are just doing minus minus. So this also you can refer. So I'll give the uh, I'll give the link of this particular problem also in the description. So thank you so much. If you have understood the problem, if you have understood my solution, if you have understood my approach, then do like this video and share with your friends. And finally, thank you so much. And we'll meet in the next video. Thank you.